Hi everyone, today's physics video is on transformers. At the end of this video, you should be able to describe the structure and principal operation of a simple iron core transformer as used for voltage transformation. And you should be able to understand the relationship between the number of turns of coil in a transformer, the relationship with the voltages and the currents, and we will be using these equations as stated over here to solve related problems in class. I also want to engage you in some critical thinking questions on how electricity is actually transmitted to your homes. This schematic diagram shows how electricity is transmitted to the domestic homes. You can see that from the power station to the various substations, the voltage is stepped up and then stepped down when the electricity is used at the industries, and then step down further when the electricity is used at the homes. Now the question is, why is there a need to step up and step down the voltages? What are the reasons to do this? Well, this is what I would like you to think about as we run through this lesson today. Transformers comes in different sizes and different types. One of the usual type that you will see is the battery charger to your laptop as shown over in the picture over here. Okay, this battery charger contains a transformer in its power cord. And different electrical appliances need different working voltages. The doorbell may work on a 6-volt supply, whereas a television may need several thousand volts. Transformers are used to step down or step up the main supply of 240 volts to the specific voltage required by the appliance. This diagram shows the basic structure of a transformer. A transformer has two coils of insulated wire, both wound around the soft iron core over here. The two coils are known as the primary coil over here and the secondary coil. And you can see from here that the primary coil is connected to an AC supply. So the question is, why do we need an AC supply to flow in the primary coil? Can we use a DC supply instead? For example, a battery that's connected to the source? Do think about it. And over here at the secondary coil is usually connected to the load. For example, the load here is the lamp. Well, let's come back to the question. Why is it that we need an AC supply and not a constant voltage supply? Think about it. Some of you may have guessed that we need an AC supply because we need a changing magnetic field. And this changing magnetic field passes through the secondary coil via the soft iron core and induces an EMF in the secondary coil. Hence, it's important to note that a transformer will not work with a constant voltage applied to the primary coil. And this shows the relationship between the secondary output voltage over the primary input voltage to the number of turns in the secondary coil over the number of turns in the primary coil. And you can see from here that this relationship between the voltages and the number of turns is also known as the turn ratio. So please remember, when they're asking for turn ratio, it's referring to the number of turns in the secondary coil over the number of turns in the primary coil. From the equation in the previous slide, the turn ratio equation, we can see that the secondary output voltage can be varied by changing the number of turns in the primary coil and the secondary coil. In diagram A, this shows the step-up transformer. It has more turns in the secondary coil than in the primary coil. In diagram B, this is a step-down transformer. It has fewer turns in the secondary coil as compared to the primary coil. This picture shows a step-down transformer in a power substation. And we know that from the principle of conservation of energy, that the output power cannot be more than the input power. That is, we cannot get more energy out of what we put in. Sounds very logical, right? So for an ideal transformer, which is 100% efficient, we have this relationship. Output power equals to input power. And recording on what you have learned for power in the previous lessons on electricity, we know that P equals to IV. So output voltage multiplied by output current is equals to input voltage multiplied by input current. So you can see for here that the equation Vs Is is equals to Vp Ip. So that forms another equation for the transformer. If you can recall, the previous equation that we learned is the turn ratio equation. So since power equals to voltage times current, or P equals to IV, if the voltage is stepped up, the current will be stepped down. Conversely, if the voltage is stepped down, the current will be stepped up. To end off, I would like to again show you the schematic diagram showing the transmission of electricity from the power station to the substation, all the way to the industry and the homes. And the question I want to pose again for you to think about is, why is there a need to step up the voltages for transmission before it's delivered to the industries and homes for use? Let's take some time to think about it. So that's it for now. Thank you very much.